Hello everybody. Today we're going to be talking a little bit about what the prospects are for snow this winter in the Washington D.C. metro area. By now everybody should know that we are in a El Nino year. Actually it's going to be a strong El Nino year, and the National Weather Service says it's highly likely that the El Nino will continue through the wintertime. So we're going to have an El Nino effect all the way through until next spring. You're going to hear people saying that when you have a strong El Nino year, the East Coast gets a warmer and wetter than normal winter. That's not always the case in El Nino years. We've had 30 inches of snow during a strong El Nino year, and we've had as little as only a trace of snow the whole winter. So there's more things going on that determine what the effect of strong El Nino will be in the DC area. Now, to have snow, you need two things. You need to have precipitation, moisture, and you need cold temperatures, and they need to happen virtually simultaneously over DC. And so a little slippage one way or the other is going to change what would be a big snowstorm to a big rainstorm. And what we need to look at is some other indicators that have been developed since El Nino was originally discovered back in the 1950s. One of those indices is called the Pacific North American teleconnection. It is, let me show you this. This is a description of the Pacific North American teleconnection indices. And basically what the indices it has a positive phase and a negative phase. The positive phase, when it's in a positive phase, it develops a deepened low between the Aleutian Islands and actually Hawaii in the northern Pacific. And that results in a ridge or a high pressure area developing either just offshore or onshore along the west coast of the United States. When that develops and when we have the PNA in a positive phase, it provides a conduit to let very cold air from the Arctic dump down into the eastern part of the United States, down in the mid-Atlantic and northeast. So what we need to happen in any winter is for the PNA to be positive, and that will set up the cold air that we need for any precipitation to change over to snow. Okay, today, what got me excited today, and I already gave out a tweet that I was going to do a video, was that one of the weather enthusiasts that I follow tweeted out a very interesting theory, a linkage that I really think has some substantial merit, and so I'd like to share that with you. First of all, let me see if we can find the right. Okay, this one I think is a good one. Okay, this is the way he did the analysis. He took all of the El Nino years from the 1880s all the way to the present, and he divided them into two groups. One group is the El Nino years where the PNA indices was positive during the during October preceding the winter. And he did the same for the El Nino years where the PNA was negative during October of that winter, just at the beginning of the winter. So he has two sets of El Nino years. And he then shows this. This is actually a roll-up map of the United States showing the temperature deviation from norm for all the Decembers, Januaries, and Februaries, and March from 1896 through 2015. The top group shows what each of those months looked like when the PNA was positive and we had an El Nino year, El Nino winter. The bottom part shows the same maps, the temperature when the PNA was negative during the October preceding the beginning of winter. And as you can see, the top maps clearly show that the temperatures are much colder during January, February, and March than average, and that when the PNA in October is negative, the winter temperatures are much higher than average. So this really shows that looking at both El Nino and the PNA phase really is predictive, at least whether we're going to get a cold winter or a warm winter. Okay. Now what I did, I decided this is really interesting. Let's graph snowfall for the DC area. I took snowfall readings for Washington Reagan National Airport going back to, I think I started in 1896 through the winter of 2003-2014. And I did a spreadsheet and did a statistical analysis of that data. This spreadsheet is a roll-up of the snowfall at Washington Reagan National Airport from November through March for each of the El Nino years that had a positive PNA. So we see that we have a column here that shows what the snowfalls were for that whole season and for each of those years. Okay, the average snowfall during this period should have been 15.4 inches. That's actually the average for the DC area for any given winter. It's about 15.4 inches total. But if we sum up and calculate an average for these positive PNA El Nino winters, we have an observed amount of 21 inches as the average. Now in statistics, you need to determine if the data that you're looking at is a normal distribution or not, because if it's a normal distribution, you can do some further analysis to indicate how confident you are that the data is not just being generated randomly, that there really is a difference between the expected value and the observed value, a significant difference. So you do a skew analysis to find out if the data is skewed or whether it behaves more like a normal distribution. That's what I did here, and it meets the criteria that this data actually does follow a normal distribution. So given that, we can then apply some statistical analysis to see, first of all, what is the probability that the difference that we see here is just random, and or whether it is a significant difference. After we do that calculation, there's only a 5% chance that this is just a random happening. That means a 95% chance that this is statistically significant. The difference between this observed average during these El Nino positive PNA years versus just any old year. Okay. Once we've done that, and since we know this is behaves like a normal distribution, we can do some further analysis to determine what the probability is for us to get above a certain number of inches of snow. And that's what we have down here. So based upon this analysis, we have a 70% chance of getting 15 inches or more of snow. Could be 30 inches, but it's at least 15 inches or more. It's about 70%. The normal year, you have a 50% chance of getting more than 15 inches. So it definitely is suggesting that since we are in a positive PNA for October, and we're in a strong El Nino year, it's suggesting that we definitely will have more snow than average. In fact, we have better than a 50% chance of getting more than 20 inches of snow this year. So I think the prospects for you snow lovers is actually quite good. It's looking like we will get more than 15 inches of snow. And we're talking about for this full 5-month period, the sum of the snow we received from November through March 2016. Okay, I'm going to leave it there for now. There's some other things that are going to start occurring towards the first week of November. We're going to get some more indicators in, and I definitely will be keeping you abreast as those additional forecasts come in. If you have any question, give me a tweet at PatPend, that's PATPEND, and I'll try and answer them. Thanks a lot.